Okay, so in this part of the video now, we're going to look at what happens when we take a radioactive unstable nuclei and what happens when they release radiation. In these sorts of questions and in these sorts of situations, you will be told what type of radiation the nucleus in question releases, or they might show you an example of an equation with the numbers in place, and as soon as you see the numbers, you'll be able to work out whether it was an alpha emitter or whether it was a beta emitter. Again, we need to use the numbers, we need to use the equations for you to fully understand this, but just to try and break it down, and you might look at this and you think, well, how on earth am I supposed to know whether it's given out alpha or it's beta? It will be really obvious in the question when you actually have a go with it. Okay, so don't panic straight away and think, oh, well, I can't do it because I don't know. It will be explained as you go through. All right, so we are going to look at an element called radon. You may have heard of radon before. It is a group 0. It's a noble gas, so it's got a full outer shell of electrons, it's an inert gas, doesn't react with anything, blah blah blah, and it also happens to be radioactive and unstable. So we're going to look at radon 222, and that's its mass number. And just so you're aware as well, it has 86 protons. So what you should be able to see there is that there's a very big difference between the 86 and the 222. So it tells you it's got a very large number of neutrons. It's got a big, the ratio between the protons and neutrons is really large. So that instantly tells you that it's going to be an unstable element. It's unstable, it's radioactive, and it's an alpha emitter. So unstable, radioactive, and it's an alpha emitter. I don't know how you spell the word emitter. So during decay, so when this element wants to decay, it will release an alpha particle. So whenever it decays, it releases an alpha particle, and that alpha particle comes from its nucleus. So during decay, a radon nucleus emits an alpha particle. Okay, so it's going to emit an alpha particle, so it's going to emit one of these. Okay, I'll put a little bit of colour around that. So it's going to emit one of them. All right, makes it look a little bit more like an element on the periodic table, wouldn't you say? Because it's got the mass number and the atomic number. But anyway, so it's going to emit an alpha particle. It's got a mass of 4 and it's got a proton number of 2. Well, it's giving this out, and these are its original numbers. So hopefully you might look at this and think to yourself, actually, I think I can see where she's going with this. If it's going to give this out during that reaction, during that decay, then these numbers are going to change. These two numbers are going to be different at the end of this decay, and that is going to be a very different element. Because what you should also recognise is that if this is losing 4 there and 2 there, so if it's losing 4 off the mass and 2 off the proton number, as soon as you change the proton number of an element, you should remember that the proton number determines the element. So if you change the number of protons, you are going to change the element. So at the end of the alpha decay, we are going to have a different element in our hands. Okay, so let's take it through the process and see what happens. All right, so we start off with radon 222. It's got 222 particles in its nucleus. So step 1, radon, what's the symbol for radon? Rn 222. So this contains 222 particles in the nucleus. So it contains 222 particles in the nucleus. During its journey from unstable to stable, it releases an alpha particle, and that alpha particle contains 4 particles. So the alpha particle contains 4 particles. So that only leaves 218 in its nucleus. So we go from 222 minus the 4, and we're left with 218. So 218 particles now remain in the nucleus. Now, 2 of those particles out of the 4 are protons. So because they're protons, that means that the element is going to change. So because the proton number has changed, the atom is now a new element. So the proton number of the element changes. Therefore, nearly spelled that right. Therefore, the element changes. So we go from radon 222 with its 86 protons. We're taking away 2, so we're going down to 84 protons. So it now contains 84 protons from 86, just in case you can't do that maths. So what's the new element? Okay, and that's the type of question that you'll get asked. Now, you won't get asked this in this much detail, like 5 steps or whatever. You will get given an equation, and it will look really straightforward, honestly. You'll look at it the first couple of times and you'll think, oh, this is a bit baffling, I'm not really sure, but I can promise you with practice that you will get there with this. And I've taught this to 2 different classes this year, and it took no time at all to pick this up. So I think we'll be absolutely fine with this. So I'm going to change my sheet of paper in a second, and we're going to have a look at this in terms of an actual equation and stuff, like the ways that we'd start to set this out in an exam question. So let's have a little look at this alpha decay then in our nucleus. Right, let me just swap the paper out. So let's start with radon. So radon 222, and it's got our 86 protons. Okay, so that is going to lose an alpha particle. So it's going to lose an alpha particle. So let's draw in our alpha particle, 4 and 2. So we take the 4 off the 222 and we get 218. We take the 2 off the 86 and we get left with 84. So if I look at my periodic table, that tells me that this has decayed into a polonium element. So it's decayed into polonium atom. So I can put PO as a symbol there, and I'm going to put a plus sign in the middle there to show that this plus this actually equals this. Okay, so it's a little bit like half equations from electrolysis, if you can remember that, where it kind of looks backwards. So it's this is breaking down into this plus this. Okay, so all that's happened is we've taken off 4 from the mass and 2 from the proton number. That is the whole process of alpha decay. So in an alpha decay equation or an alpha decay example, you take 4 from the mass and you take 2 from the proton number. That is the same with whichever element it is that you are investigating. Okay, so we can summarize that. So when an alpha particle is emitted, from the nucleus the nucleus loses 2 protons and 2 neutrons. Okay, so important things here. I'm going to write these in 2 different colours because why not? The mass number decreases by 4. And then the atomic number decreases by 2. And that is the rule all the time, always, with alpha decay. Now, you might see the alpha decay written as either an alpha symbol 4 and 2, or if you remember back just at the start, we said that an alpha particle can also be written as a helium nucleus, so you might see it also as He 4 and 2. Either of these are accepted. I can't tell you which one they're going to choose to do in the exam. You know, it's if I could read the examiner's minds, that would be amazing. But they might do either of those. But whatever they used in the question, you use in your answer. That's what I'd say. Just to make sure that it's consistent. But if they don't give you anything in the question and you can write your own, then just have a go and just do it with whichever one that you want. That's absolutely fine. Okay, so the rules every time this happens, the mass number decreases by 4 and the atomic number decreases by 2. It's always the same in every alpha decay equation. So when you are doing these equations, you'll be given a periodic table. You will get a periodic table in your exam. If something like this is on the physics exam, then they're probably going to give you a periodic table. They won't put this in the chemistry exam because it is a physics topic. But in the physics exam, they'll either give you a small section of the periodic table, or they might give you some elements to choose from. But what you'd be expected to do is, when you've decreased the numbers, you will then use the new atomic number to identify the new element. So all I did literally up here was I knew that my radon was going to lose 4 from the mass and 2 from the proton number, from the atomic number. So then I just wrote my numbers in and then just looked at my periodic table. I have a periodic table on the wall to tell me that it's polonium 84. Okay, so really simple, really straightforward. Just use the proton number to tell you what the element is. Now, don't panic if the mass number does not match what's on your periodic table. Okay, it doesn't matter. The periodic table on my wall says that says polonium has got a mass, a mass of 209. Now that's fine. That doesn't match, because that's just telling me that this is an isotope of polonium that's got 218 mass, whereas the one on my wall's got 209. All right, that's fine. It does not matter. What matters is this proton number. Whatever that proton number is tells you what the element is. Okay, so don't panic if this doesn't match what's on the sheet of paper, what's on the periodic table. That doesn't matter. It's what this says. Okay, that's just an added bonus. All right, so I'm going to write that down because I know what you're all like and I don't want you to worry about it. So when you have written your alpha decay equation, use the new atomic number to identify your elements. It does not matter if the mass number in your calculation should say is different to the mass on the periodic table. It really, really, really doesn't matter. Honestly, it doesn't matter. It's not the end of the world if the mass is different. Like I've said, it's all about the fact that there are isotopes. It doesn't matter that the numbers are different to what's on the piece of paper. As long as you can work out the calculation and you can use the atomic number to work out your new element, that's all that matters. Okay, so don't stress about it whatsoever. So I'm going to have a little go of showing you some examples at how this might work, and then that's pretty much going to be it for the end of this video. It's not an awful lot today. You're going to have some little worksheets to have a go of. Just make sure you can work them out, and then you'll be cracking on with some Seneca too. So let's go through this video and have a little look. We've done radon, so I won't do radon again. Right, we're going to look at, is this thorium or thallium? I never know the difference between these ones. It's thorium, right? So we're going to go for some thorium. So let's just go for some clean paper. Give ourselves a title. Alpha, decay, equations. And I promise that this will be fine. Don't worry, don't stress out. So, periodic table, thorium, TH. It has got a mass of 230 and it has got 90 protons or an atomic number of 90. Okay, so this is going to decay. It's an alpha emitter and it's going to emit an alpha particle. So I'm going to draw in our arrow and straight away we can write in our alpha particle 4 and 2. Okay, so I need to work out what is my missing element. So what is this now going to become now that it has emitted this alpha decay? So really simply, I'm going to look at my numbers and it's going to tell me that I'm going to have 230 minus 4 on the top, and I'm going to have 90 minus 2 on the bottom. So that and that. So we're going to have 88 is going to be our new atomic number, and our new mass is going to be 226. I nearly got away without making a mistake there. 226. So I'm not really fussed about this mass number. That's not going to tell me an awful lot. It just tells me the mass of my new element. But I am interested in this 88, and that is going to tell me my new element. So I'll have a little look at my periodic table, and it tells me that my new element is radium. And radium is Ra, and that has got an atomic number of 88. And according to my calculations, a mass of 226. Now, it also has 226 on my periodic table as well, so that one worked out quite nicely. So that is one example of an alpha decay equation. Simple as that. Okay, so very much like the radon one that we just did at the start, where we went from radon down to polonium, and then from thorium, and we worked out that it was turning into radium. There's another way that you could write these as well, and that's looking at what you've ended up with to try and work out what you started with. All right, so I'll do 2 examples of these, and then honestly, I don't really think there's a lot more that I need to do. Obviously, if you feel like you're still struggling, then just tell me in lesson, and I'll do as much as I can. But I think we'll be okay with these. I've got confidence in you. So you would start out with an equation which will give you element X. And we're going to try and work out what element X is. And it tells you that this decays into an alpha particle. And it tells you that it makes thorium. So it turns into thorium. So we started with thorium there decaying, and this time this turns into thorium. thorium, 230 and 90. So let's see if you can use your maths brains, which you might need, because I know after this session you'll be doing maths online. So let's see if we can work this out. So if in this question we're going from here to here and we're subtracting these numbers, then what do you think we're going to have to do in this situation where we're going from here back to here? Oh, that's right, I can hear you all saying it. We're going to add them together rather than taking them away. So up here, we're going to have 230 plus 4, and we're going to have 90 plus 2. We're going to add those numbers back together. So we've now got an element that has got a mass of 234 and a proton number of 92. It's turned into the alpha particle. Let's just write the rest of the equation in just to keep it nice and neat and consistent. So we've got 234 mass, 92 atomic number. So I'm going to focus again on the 92. Look at my periodic table, and it tells me that my element is uranium, which is just a nice capital U. And on the periodic table on my wall, it says it's a mass of 238, so it's 4 different, but that doesn't matter. It's absolutely fine. The thing that is important is that number there. Okay, that atomic number tells me what the element is. All right, so I'll do one last example like this, and then I think that'll be plenty, and you guys will be able to crack on with the worksheets and whatnot, and I think you'll be absolutely fine. I have no worry whatsoever about this. Okay, so one last question, one last example is let's have a little look. So we've got element X again, and that's turned into an alpha particle, and it's turned into lead, PB. And lead has got a mass of 214 and an atomic number of 82. So I'm going to do the exact same thing I did in the last one, and I'm going to add 214 and 4, and I'm going to add 82 and 2. I'm going to add them together. Okay, so that tells me that element X, oh, I shouldn't have done that, should I? Sorry, element X, we'll write it 3. What's a little bit of scribbling? It's got a mass of 218, 214 plus 4, and 82 plus 2. It's got an atomic number of 84. Write the rest of our equation back in. 82. So lead has been created from 84 polonium. So we've almost gone full circle, because polonium was our example at the start when we were talking about radon. And we've come back down to polonium. So polonium 84 will decay into lead and an alpha particle, a helium nucleus. They're our alpha particles. So that is 2 different examples of how to do these equations, either when we start with this and this is our unknown, or when we start with this and this is our unknown. Okay, so there's the 2 different varieties of how to do those equations. All right, so when you get given these questions, you'll be given an element and you'll be told it's an alpha emitter, or you might be given something like this. So you might be given this and asked to work out what the missing section is, which is really easy, because look at the difference between the numbers. If you can work out the difference between those numbers, then it tells you exactly what you should have in the middle there. And likewise, if it was that and that, then you just use the numbers again to work out the missing numbers. The whole point is to work out these missing mass numbers and missing atomic numbers, and then use the atomic number to figure out the element. Okay, so I hope that was straightforward enough. You're going to have a bunch of questions to have a go of. Just give them a go, see how you get on, and obviously you know where I'll be if you need any help. So I hope that video was nice and clear. Again, thank you for watching, and I'll speak to you in class.